Hello everyone. Today we will discuss DEE fourth unit topic electrical machines. In that today I will complete the first topic generation of rotating magnetic field. If you observe three-phase induction motor, generally the motor will convert electrical energy into mechanical energy, which it is supplied to a different types of loads. For example, AC motor operator and AC supply. These are classified into two types. One is synchronous motor, another one is single phase, three phase induction motor. Depending upon supply, they are classified into motors in two ways. One is single phase, another one is three phase. Now we will study the three phase induction motor. Especially this three phase induction motor used in industrial applications. Most of the industries they use only three-phase induction motor because they will get more rating and more efficiency by using three-phase induction motor instead of using single-phase induction motor. The three-phase induction motor is a single excited AC machine. It means we will give supply to only stator winding directly and connected to the AC source, and it is rotating winding receives its energy from the stator by means of induction. There is no direct connection between the rotor and stator. Exactly the same way in this case of secondary. It is similar like secondary of a two-winding transformer receives its power from the primary winding. It means if I given supply to primary of the transformer, if I short circuited the secondary winding, it's act like a rotating part. It is a stator. It is a stator part and it is rotor part. Similar like a transformer, three-phase induction motor can also compare with the transformer. Now coming to the construction of three-phase induction motor. Mainly any motor consisting of two parts. One is rotor part, another one is stator part. The rotor is separated from the stator by small air gap only in the range of from 0.4 mm to 4 mm depending upon power rating of the motor. If you observe the construction of stator, we have stator slots, stator frame, stator core, stator teeth. Observe this. This is a stator frame outside of the motor. This is stator slot. This is stator teeth. In this area only, we will place the winding. For three phase, we are displacing three windings with 120 degrees displacement. Coming to construction of rotor, depending upon construction, there are two types of rotors are there. One is squirrel cage rotor, another one is wound or slip ring rotor. It means we have slip rings in rotor side. If you observe the construction and diagrams, you can easily identify what is these two types. Coming to the squirrel cage induction motor, it is a squirrel cage induction motor. There is no slip rings. In these slots, we are using copper and aluminum bars. Those are short circuited at the end of this copper end rings. Coming to the slip ring induction motor, in the shaft we are used this winding and these are connected to the slip rings. These three slip rings are we are using over here RYB. RYB. These are used to connect external resistance. In the next classes, we will observe what is the use of this external resistance, how it will help to get maximum torque at starting only. Now, after this comparison between these two slip ring and squirrel cage rotor motors, now I will explain comparison between these two types of rotors. Now, if I go with wound or slip ring rotor motor or squirrel cage rotor motor, where we use these two types of rotor construction. First one is this rotor consisting of three-phase winding similar to the stator only. But in case of squirrel cage rotor motor, rotor consisting of bars which are shorted at the end with the help of the end rings. Here we can observe there is no wires outcome from the rotor, but here we can get the wires from the rotor by using slip rings. Now coming to second point, external resistance can be added. Previously we observed here, you can observe over there, there we can connect extra resistance in case of slip ring induction motor. But in this case there is no external resistance connected to added. The speed control will be possible by using external resistance. This is very important. In this case there is no speed control from the stator side, only possible from the stator side. There is no speed control from the rotor side. Why? Because there is no additional resistance in this case. In slip ring and bushes are presented. Now only we observe the diagram. Here we have slip ring induction motor have these slip rings. In case of slip ring induction, name only indicating this. Now complicated construction and costly. Here we are using slip rings, but in this case there is no slip rings, and we can directly robot construction and the cheapest. Why? Because there is no slip rings used, there is no external resistance. Why? Because most of the motors are constructed as a squirrel cage induction motor only. Now here, why? Because of using slip rings, we occurs more maintenance cost. Here there is no maintenance. Here we can observe due to the resistors and brushes, we will get low efficiency and low power factor. In this there is no slip ring, that's why we will get the more efficiency. High starting torque can be applied. Now only we discuss before topic. If you add more resistor, you will get maximum torque at starting. Here there is no maximum starting torque. Usually these are used for lifts, cranes, elevator, where we require high starting torque. Where we require high starting torque. Here we will use hands, lens, and grinders, etc. Try to observe these examples. These are used for lifts, cranes, elevators, where we require high starting torque. Here we don't require any high starting torque. We can simply go with fans, lens, and grinders. Coming to our topic, the first topic is production of rotating magnetic field. If I given three-phase supply, by using three winding, is a displaced space of 120 degrees. We are well known about how the winding is displaced 120 degrees. If I given this supply to the motor, it will produce three magnetic fluxes. Whenever you given supply to any winding, it will produce flux, isn't it? In this flux, there is a 120 degree displacement due to r. Here we can observe r, y, b, that is minus 120 minus 240. We can also write plus 120 also. The resultant flux is equal to, the phi of t is equal to sum of these three fluxes produced in that motor at one point. Now observe this wave, observe this winding diagram. R Y B. You can observe this R Y B. This is a simple vector diagram. R Y B. Now observe this waveform. This is similar like a three-phase supply. First one is started from the 0 degrees. Second waveform started from the 120 degrees, and third waveform is started from the 240 degrees. You can observe this. This is a complete waveform. First waveform, here 180 and then 360. Here we can write 60. Now how the rotating flux is produced? Now I am taking at this point. At this point, I am changing the color. Now observe this. At this point, there are three fluxes. First one is, it is phi b, and phi b is nearly equal to the, try to observe this, this is a positive value. If I am assuming it is a 1, here you will get nearly 0.8665 m. It is nothing but a phi m sine my minus 240 because of delay functioning. And here at this point phi r is equal 0 only, and the last at this point you will get minus values. Phi y is equal to minus 0.8665 m. Now we know the total flux is equal phi r plus phi y plus phi b. Or add this all this function, you will get 1.5 times of phi m. You can check this, check over here. The vector sum is equal to the first point at the 0 position. What is the phi r value? 0. And the second position phi y is equal to 0.8665 mm. Phi b is equal to 0.8665 m. We know all these values. Now the resultant flux is equal to phi t is equal to under root of phi y whole square plus phi b whole square plus 2 phi y phi bm cos phi. The phasor sum phi y minus resultant flux is equal to this value. And if you substitute all the values, we know the angle between these two, phi y and phi b is equal to 60 degrees. We already discussed in three phase supply also. Similar like that, you will get root 2 pi into 1 plus pi m. That angle is equal to around. Finally, you got how many phi m's are there? 2 phi m. We take common 1 plus cos phi m. And finally, you got 2 phi m cos phi by 2. That value is equal to 2 into cos 0.886 into phi m into cos 60 degrees by 2. You will finally you got 1.5 times of phi m. It is a resultant flux when at omega t is equal to 5 degrees. Second condition we have discussed, omega t is equal to 0 we have done. The second one is when omega t is equal to 60 degrees. You can observe in the waveform also. Observe this, the waveform when omega t is equal to 60 degrees. When omega t is equal to 60 degrees, here at this point you will get only phi r value, and the phi b value is equal to 0. Observe this, phi b value is equal to 0 and the phi y is equal to around minus 0.866 phi m. I would like to add these three values. Now observe this, when omega t is equal 60 degrees. Now only we saw in the diagram IR is equal to plus value of 0.865 m and phi y is equal minus value of this and phi b is equal to 0. If you add these three, you will get phi of t is equal 1.5 times of phi m. 1.5 to 5 at the 60 degrees, how much value you will get? 1.5 of maximum value. Observe this three diagram how it is rotating. When angle is equal to 0 degrees, when angle is equal to 0 degrees, the resultant flux is at this position. When angle is 60 degrees, the resultant flux is at the shifted into 30 degrees, and the angle is 120 degrees. It is again shifted into the one more 60 degrees, and the last one is angle is 180 degrees, is shifted to the opposite side of the first one. If you observe all diagrams, first resultant flux is at over there, and second resultant flux is there, and third one is over there, and final one is about to there. If you observe this diagram, you can observe it is rotating flux. Our concept is how the rotating flux is produced in case of three-phase induction motor. If you observe this from starting, it is there around, I am assuming it is a 0 degrees. Next it is shifted to 45 degrees, and again it is shifted to one more 45 degrees, and last it is shifted to 45 degrees. The total angle is 180 degrees. This way the rotating magnetic flux will produce in case of three-phase induction motor. Try to observe this similar way where we can produce the rotating flux at omega t is equal to 180 degrees. If you observe from the above discussion, it is clear that the resultant of the three alternative flux separated from each other 120 degrees. It has rotating field constant of 1.5 times of phi m, and it is moving around the machine peripherally. If you observe this, first it is over there, and second there, third and three. It is rotating magnetic flux, the value of 1.5 times phi m. I hope all of you clear. If you have any doubt, and watch the video once again, it will be helpful to your examinations. In exam, they may ask direct question. Explain the rotating magnetic field in three-phase induction motor. Thank you.